Alright, so in this video, I'm going to solve the problem 32 to the power of 200 minus 2 to the power of 999. So to solve this, I'm going to first rewrite 32 as 2 to the power of 5. So I get 2 to the power of 5 to the power of 200 minus 2 to the power of 999. And this turns into 2 to the power of 1000 minus 2 to the power of 999 because the 5 and 200 multiply. Now to solve this, I'm going to rewrite 2 to the power of 1000 as 2 to the power of 99 plus 1. So I get 2 to the power of 999 times 2 to the power of 1 minus 2 to the power of 999, which is equal to 2 to the power of 999 times 2 minus 1, which is equal to 2 to the power of 999.
Alright, so in this video, I'm going to solve the equation 1 to the power of x plus 10 to the power of x is equal to 100 to the power of x. So, to solve this, I'm going to first start by rewriting this as 1 to the power of x plus 10 to the power of x is equal to 10 squared to the power of x. Now from here, I'm going to look at the term 1 to the power of x. Well, let's say we have 1 to the power of any number, like 1000. This is still equal to 1. And even if we have 1 to the power of infinity, this is still equal to 1. So no matter what value x could be, it's still going to be 1 to the power of x will still be equal to 1, meaning we can just ignore the x and just say this is 1 plus 10 to the power of x is equal to 10 squared to the power of x. Now from here, if I have something in the form a to the power of m to the power of n, this is equal to a to the power of m times n. And a to the power of m times n is the same thing as a to the power of n times m. Well, if these two are the same, and a to the power of m times n is equal to a to the power of m to the power of n, this should mean that a to the power of n times m is equal to a to the power of n to the power of m. So in simpler terms, a to the power of m to the power of n is equal to a to the power of n to the power of m. So, for 10 to the power of 2 to the power of x, I can switch the values of 2 and x. So now I get 1 plus 10 to the power of x is equal to 10 to the power of x to the power of 2. Now from here, I'm going to let 10 to the power of x equal to the variable y. So if I substitute in y for 10 to the power of x, I get 1 plus y is equal to y squared. Now I'm going to subtract y and 1 on both sides. So I get y squared minus y minus 1 is equal to 0. Now, what we have here is a quadratic equation. And to solve this, I'm going to be using the quadratic formula, which is negative b plus or minus the square root of b squared minus 4ac all over 2a. So in this case, I'm going to look at the coefficients. A is 1, b is negative 1, and c is negative 1. So I get y equals negative of negative 1 plus or minus the square root of negative 1 squared minus 4 times 1 times negative 1 all over 2 times 1. And now this is equal to 1 plus or minus the square root of 1 plus 4 over 2, which is equal to 1 plus or minus the square root of 5 over 2. So I get that the value of y is equal to 1 plus or minus the square root of 5 over 2. However, we aren't done yet, because remember, we're solving for the value of x and not y. And we let 10 to the power of x equal to y. So I get 10 to the power of x equals 1 plus or minus the square root of 5 over 2. Now, this gives me two equations. I get 10 to the power of x is equal to 1 plus the square root of 5 over 2. And I get 10 to the power of x is equal to 1 minus the square root of 5 over 2. So I'm going to first start with 10 to the power of x is equal to 1 plus the square root of 5 over 2. Well, to solve this, we want the x over here, which is an exponent, to turn into an actual term. And to do that, we're going to use logarithms. So I get log 10 to the power of x is equal to log of 1 plus the square root of 5 over 2 when I take the log on both sides. And now, if I have something in the form log a to the power of b, I can move this exponent b to the front, so this turns into b times log a. So I can move x here to the front, and I get x times log 10 is equal to log of 1 plus the square root of 5 over 2. Now, I'm going to divide both sides by log 10 because x, we want to isolate x. So these two cancel out, and I get x is equal to log of 1 plus the square root of 5 over 2 over log 10. Now, if you already know, log 10 is equal to 1. So x is simply equal to log of 1 plus the square root of 5 over 2. And now the exact value of this is 0.209. So this is one solution of x. However, don't forget that we have the equation 10 to the power of x is equal to 1 minus the square root of 5 over 2. So to solve this, we're doing the same thing. We're going to be using logarithms. So I get log 10 to the power of x is equal to log of, this time 1 minus the square root of 5 over 2. Now I can move x down, so I get x times log 10 is equal to log of 1 minus the square root of 5 over 2. And we don't even have to divide both sides by log 10 because we already know log 10 is equal to 1. So we can just get rid of it, and I get x is equal to log of 1 minus the square root of 5 over 2. Now, the log of 1 minus the square root of 5 over 2, the exact value of this is actually going to be negative 0.209 plus 1.364i. So there is an imaginary number in this. So this is my second solution to this equation. Now, if you haven't already, please make sure to subscribe, leave a like, and share this to any of your friends or family. Thank you.
Alright, so in this video, I'm going to solve the equation x to the power of 2 minus x to the power of 3 is equal to 80. So, to solve this equation, I'm going to first start by subtracting 80 on both sides. So now I get x to the power of 2 minus x to the power of 3 minus 80 is equal to 0. Now from here, I'm going to replace 80, negative 80, I should say, with negative 16 minus 64. Now, I'm going to rewrite this as, I'm going to first rewrite negative 16 as negative 4 squared, and negative 64 as negative 4 to the power of 3. And I'm going to group x squared with negative 4 squared, and x to the power of 3 with negative 4 to the power of 3. So now there's two properties that I'm going to use. And before that, I'm going to write this as x squared minus 4 squared, and I'm going to group this minus x to the power of 3 plus 4 to the power of 3. We put this plus because this negative sign distributes. Now, if I have something in the form a squared minus b squared, this is equal to a plus b times a minus b. And if I have something in the form a to the power of 3 plus b to the power of 3, which is this is equal to a plus b times a squared minus ab plus b squared. So for x squared minus 4 squared, it's going to turn into x plus 4 times x minus 4. I have this minus a to the power of 3 plus b to the power of 3, or in this case, x to the power of 3 plus 4 to the power of 3 is going to turn into x plus 4 times x squared minus 4x plus 16. Now, because both of these terms have x plus 4 in them, I can factor out x plus 4. So I get x plus 4 times x minus 4 minus x squared minus 4x plus 16 is equal to 0. Now from here, this is equal to x plus 4 times x minus 4 minus x squared plus 4x minus 16. I just distribute the negative sign, is equal to 0. And let's simplify this even more. I get x plus 4 times negative x squared plus 5x minus 20 is equal to 0. So I get two equations from this. I get x plus 4 equals 0, and negative x squared plus 5x minus 20 is equal to 0. So first, for x plus 4 equals 0, all we have to do is subtract 4 on both sides, and we get x is equal to negative 4. Now, for negative x squared plus 5x minus 20 equals 0, well, first off, we have a negative sign in front of x squared, so I'm actually going to get rid of that by multiplying both sides by negative 1. So I get x squared minus 5x plus 20 is equal to 0. And now, to solve this, I'm going to use the quadratic formula, which is negative b plus or minus the square root of b squared minus 4ac all over 2a. So in this case, a is 1, b is negative 5, and c is 20. So I get x is equal to negative of negative 5 plus or minus the square root of b squared, which is negative 5 squared, which is 25, minus 4 times a, which is 1, times c, which is 20, all over 2a, so 2 times 1. And this is equal to 5 plus or minus the square root of 25 minus 80 over 2, which is equal to 5 plus or minus the square root of negative 55 over 2. Now, this is equal to the square root of 55 times the square root of negative 1 over 2. And the square root of negative 1 is equal to the imaginary number I. So I get 5 plus or minus the square root of 55i over 2. So this is two more solutions to this equation. Thank you for watching. Please make sure to subscribe, leave a like, and share this to any of your friends and family.